Hello again, Tom from Every Step Calculus, everystepphysics.com. People have asked, me, how do you get physics? I put physics in my calculator and it doesn't work. Well, you got to buy my programs first, and then I send them to you via email, zipped, and then you follow the instructions and load them into your titanium calculator. And then you put physics in here according to instructions with the two open and closed parentheses, which tells the calculator that you want to do a program, and you're on your way. So we put physics in here now. Press enter, and we're going to find springs, because anything we're to deal with springs, we're going to springs in the menu. So I went up with the cursor to go to the bottom of the alphabet here. We're at the V's, and close to the S where springs is involved here. There's springs. Press enter. And we're looking for a horizontal because they mentioned horizontally in here. Horizontal springs, versus a vertical spring. Horizontal springs, there's not much, if any, gravity involved, with the spring. Vertical spring there's 9.81 meters per second squared there for acceleration. So anyways, we scroll down to what's given here. I always advise everybody to on the side of your paper, when you do a problem like this, 1.20 kilograms mass, you put m equals 1.2 on the side of your paper. Then right below it is spring compressed. Let's see, a distance of 0.3 meters. When anything's compressed or stretched, it's considered an x value. So I put down x equals 0.3 meters. I do the conversions for you in case they put centimeters or whatever they might put, or feet or inches, whatever, to screw you up. Physics professors love that. And most of this stuff is dealing with algebra, switching things out of the formula and then finding that instead of what the formula actually tells you when you're looking at it. It's horizontal. Let's see, and then we have the distance that's given is, so you put down displacement, 0.1 meters from equilibrium, and they have velocity in here for 2 meters per second. So you have that all on your paper here, these four things, mass, x, velocity, and displacement, d. And we're asked to find the amplitude of the motion, the spring constant, and then what's the maximum speed of the mass, okay? Speed is a scalar property. It has no angle. Velocity does have an angle, but they're both the same for our purposes, So anyways, we scroll down to what's given. Here's M, X, V, and D. Press enter. And we're finding a spring constant given the mass, initial velocity, compression, and displacement. Going to enter the mass, you have to press alpha first before you enter anything. These entry lines in my programs, okay? So we're going to press alpha 1.2 kilograms. We choose that. Initial velocity, alpha 2. That's number 4. You can press the numbers before here, or you can scroll down, whichever you want. And I tell you about the stretch and compression. And then we want to put in the compression part of it, compressed, how far this spring is compressed. Alpha 0.3 meters, and the displacement is alpha 0.1. So I always give you a chance to change in case you made a mistake, but this is exactly correct. We say it's okay. And amplitude is 0.3 meters. When you compress a spring from its original length, which is L, and you compress it by 0.3 meters, well, that's going to, in frictionless situation, it's going to go back and forth. Okay, and it's going to go 0.3 is amplitude on one side and 0.3 is amplitude on the other. And then we're going to find the initial velocity. So this formula here is what we use for that. Angular velocity is 2 divided by the square root of amplitude squared minus the displacement squared, etc. It turns out to be 7.07 rads per second. This is angular velocity, this omega sign here, W. And then we find the spring constant by using this Hooke's law formula here. And it turns out to be 60 newtons meters. V max is always the angular velocity times the amplitude, etc. If we want to see the answers again, we can do that. Pressing 1, go through all of them quick. And then we say no, and then we goes back to the new problem or the main menu. Pretty neat, huh? Everystep.physics.com. Go to my site, buy my programs, and pass physics. Tough stuff to learn and think about and study. You don't even know what to study, really, what to memorize and stuff. So these programs really help in your homework and whatever you do with them, you know. So good luck in your classes, and you can contact me by phone or whenever I tell you how to do that when you buy my programs. I'll help you with physics or calculus, you know, the actual problems or how to work my programs, etc. So good luck in your classes. Have a good one, okay?